In this lecture, we will discuss about the asymptotes. So first we define what is asymptote. So we define asymptote is a straight line which touch a curve at the infinite distance from origin, but the point does not lie wholly at the infinity. So this is the definition of asymptote. So suppose we have a x-axis, this is origin, and this is y-axis. So we draw a curve, that means we take a parabola whose center is origin, and we take a straight line which so suppose the position of the curve tends to infinity, but when the curve touch this line at that point, the point does not lie at the infinity, does not lie wholly at the infinity, मतलब infinity से कहीं भी पहले टच कर जाएगी, that point does not at the infinity. Okay, so which touch a curve at the infinite distance from the origin, but that point doesn't lie at wholly at the infinity. So infinity से कहीं पहले टच कर जाएगी, that line is said to be the asymptote line. So we write the equation, that means y is equal to mx plus c. So we represent the asymptotes by a line y equal to mx plus c. So when we obtain the value of m and c, so we see that both are finite. So we write down as m and c, both are finite. So when we obtain the asymptotes, there are basically two types of asymptotes. One is parallel asymptote or second is oblique asymptotes. So when we obtain the oblique asymptotes, we use this thing. That means we obtain the value of m and c and put in the y equal to mx plus c. So we obtain the oblique asymptotes. So for obtaining the oblique asymptotes, we use the older formula. Any particular equation is given. So we start with one example. So first we write down the types of asymptotes. So one is oblique asymptote, and the second is parallel asymptote. So oblique and parallel asymptote. So for obtaining the parallel asymptotes, means asymptote parallel to x-axis or parallel to y-axis. So as per parallel to x-axis, we put the value of highest coefficient of x equal to 0. So we get the parallel asymptote for x-axis, about x-axis. If highest coefficient is constant, so we do not get the parallel asymptote of x-axis. Okay, so we will start with the first one, that means oblique asymptote. So for obtaining oblique asymptote, Obtaining oblique asymptote, we follow the formula. We put y is equal to mx plus c in the given equation. Okay, and equate equating to 0 the coefficient of highest power of x. Then second highest power of x, and so on. This basically depend upon the degree of the particular equation. Degree, or we can say that the power. So suppose any particular equation. So we take an example. We write down obtain the value of m and c. Value of m and c. So you remember the one thing, that means the equation has degree n, have n asymptotes. N asymptotes. N asymptotes which may be real or may be imaginary, but total number of asymptotes are n. Okay, so we remember this thing. So when we solve the problems related to that, so we start one question. So find asymptotes of the curve x cube minus 6 x square y plus 11 xy square minus 6 y cube plus x plus y is equal to 0. So this is our equation. So now we see that what is the degree of this equation. So the degree of this equation is 3. Highest degree is 3. So means this equation having 3 asymptotes. Okay. The degree of this equation is 3. So we write down the highest degree of the given equation is 3. So this has 3 asymptotes. Okay. Of 3 asymptotes which may be real or which may be imaginary. So to get the asymptotes, so we here we use the traditional formula. That means we put y equal to mx plus c. So we can consider this as equation number 1. So put y is equal to mx plus c in equation 1. We get, so first equation is x cube minus 6 x square into mx plus c plus 11 x into mx plus c to the whole square minus 6 y cube. Y cube we put as mx plus c to the whole cube. So we put mx plus c to the whole cube plus x plus mx plus c is equal to 0. Okay. So when we put y equal to mx plus c, so then we simplify this as x cube minus 6x square. 6x square. So this gives us 6m x cube plus 6x square into c. 6x square into c plus we open the whole square of mx plus c. So this gives us 11x m square x square plus c square plus 2mxc minus 6 mx plus c to the whole cube. So whole cube a plus b to the whole cube, we have a cube. A cube means mq x cube plus b cube. B cube means c cube plus 3ab. 3a square b or so 3 a square b. A square means m square x square into c or plus 3 mx c square or plus x plus mx plus c. So this is the lengthy method, but we start with the basic method. So now we move to the further methods. Now we simplify this as x cube minus 6 mx cube plus 6 x square into c plus 11 m square x cube plus 11 x c square plus 11 to the 22 22 m c into x square minus 6 m cube x cube minus 6 c cube minus 6 3 ja 18 m square x square into c minus 6 3 ja 18 m x c square plus x plus mx plus c is equal to 0. Now we take the highest degree terms, that means coefficients of highest degree terms. The first is x cube. So take the coefficient of x cube. This is 1. 1 minus 6m. So we consider 1 minus 6m coefficient of x cube and plus 11m square plus 11m square and last term this is minus 6m cube minus 6m cube. So minus 6m cube. Now we move the second highest, means x square, coefficient of x square. So you take the coefficient of x square terms. So coefficient of x square is 6 x square c. So we write down 6 x square c. So means 6 c. Next is 22 mc. 22 mc. So this is next term. So 22 plus 22 mc. Now next term is 18 m square c square. So 18 minus 18 m square c. Okay, so this is the x square terms. Now third, we take the coefficients of x, second highest. The coefficient of x means 11c square. So coefficient of x is 11c square. So first we have 11c square. So this is 11c square. Next term is minus 18 mc square. So minus 18 mc square or plus x or plus m. So we write down as minus 18 mc square, or next term is plus 1 or plus m, and plus remaining terms. Remaining term is constant term. So one term is plus c and the previous term is minus 6c cube is equal to 0. Is equal to 0. So now equating to 0 the coefficients of x cube, x square, x and constant, we get, so first is 1 minus 6m plus 11m square minus 6m cube is equal to 0. So So this is our equation number 2. Second equation, we have a 6c plus 22 mc minus 18 m square into c is equal to 0. Third equation, we have 11c square minus 18 mc square plus m plus 1 is equal to 0. So this is third, this is fourth equation, and last we write down as minus 6cq constant, so is equal to 0. So now from equation 2, so this equation is purely based on m, so that means we obtain the value of m. So from equation 2, so we write down this as 6m minus 11m square plus 6m minus 1 is equal to 0. So we find the factor. So we find this is the cubic equation. So first we find by using the trial method. So using the trial method, we obtain the first factor. So when we obtain the first factor, for trial method, we put the m equal to 1. So we try to put the values of m equal to 1 minus 1, which satisfy the above equation. So when we put m equal to 1, so 6 into 1, 1 raised to the power 3 is 1, minus 11 plus 1 minus 1. So this gives us equal to 0. So 6 plus 6 is 12, 12 minus 12 is equal to 0. So means satisfy. So it shows that the first factor is m equal to 1. So m equal to 1 is the first factor. So one factor we obtained. Now remaining factor we can obtain easily. So m minus 1 means first factor is m minus 1. So this is the cubic equation. You remember how to obtain the other factor. So when we have cubic equation, so we write down the first factor 3 times. M minus 1, M minus 1 and M minus 1 is equal to 0. Now the first term is 6m cube. So we have write the first factor m minus 1. So how to get 6m cube? When we multiply this factor by 6m square. When we multiply this factor by 6m square. So we see that the first term will be 6m square into m. So 6m cube. 6m cube minus 6m square. Minus 6m square. But we have how many m square? Minus 11m square. We require how many m square? 5m square. So we do minus 5m. We multiply by minus 5m. So we write down a minus 6m square minus 5m square equal to minus 11m square, or minus minus plus. So this gives us plus 5m. How many m's we require? 6m plus 6m. So plus 5m or plus 1m. So multiply by 1, the third factor. So we obtain this equation. So now we take m minus 1 as common. So this gives us 6m square minus 5m plus 1 is equal to 0. So now we obtain the factors of this quadratic equation. So how to obtain the factor of quadratic equation? Do we factorize? So 6 1 ja 6, so 2 3 ja 6. So 6m square minus 3m minus 2m plus 1 is equal to 0. So here we take 3m as common. So 3 2 ja 6m, 2m minus 1, or minus 1 we taken as common, 2m minus 1 is equal to 0. So we get the factor as 2m minus 1 and 3m minus 1 is equal to 0. So m we can obtain. So we have the factors. So you can write down the factors. So first factor we have m minus 1. So the total factors are m minus 1, 2m minus 1 and 3m minus 1. So what is the value of m? So value of m is equal to 1, or 2m minus 1 equal to 0 gives us m equal to 1 by 2. So m equal to 1 by 2 or m equal to 1 by 3. So we have three values of m because we have third degree equations. We have three asymptote of this. So we get the three values of m. Now we obtain the value of c. So when we obtain the value of C, so for obtaining the value of C, we can use the equation. So you can use the equation number 2 for obtaining the value of C. So now from equation number 2, we can see that means when we take C as common, so C is the common from all three terms. So C into something is equal to 0. So gives us the C, that means M is not equal to 0, but C equal to 0. So C equal to 0. So the value of C equal to 0. Now, so for finding the value of C, so we can write down as C, we can taken as common. So C into 6 plus 22m, 6 plus 22m minus 18m square, minus 18m square is equal to 0. So here you want to put m equal to 1. So suppose we put m is equal to 1 here. So C into 6 plus 22 minus 18. 6 plus 22 minus 18 is equal to 0. So that means this gives us 10C is equal to 0. So this gives us C equal to 0. So this gives us C equal to 0. So this gives us C equal to 0. So similarly, you can put any value of m, we get the C equal to 0. So when we get C equal to 0, now you can put the value of C in last equation. So we satisfy that equation also. Okay. So now the asymptotes y is equal to mx plus c, or y is equal to, when we put m equal to 1, so gives us y equal to x, c equal to 0. When we put y equal to 1 by 2, so this gives us 1 by 2 into x. So this is our second asymptote. And when we put m equal to 1 by 3, so 1 by 3, this is our third asymptote. So this is our third asymptote. So we have a third degree equations having three asymptotes. So y equal to x, y equal to x by 2, or y equal to x by 3. So we three asymptotes. Now this is the traditional method to solve the asymptote. That means when we put y, so taking more time. That means when we solve the equation by squaring q, remember all the formulas. But we have second method for solving such type of problems. So when we solve the problems related to oblique asymptotes, so we can follow the formula. So we write down or we discuss this second method. So another method to solve oblique asymptotes. So we start the working procedure for writing the asymptote of cubic equation or biquadratic equation or quadratic equation. So first step we follow that to find. So we are taking the general form, that means a equation which have degree n, any curve which has degree n. So we find phi n m. First we find phi n m. Find phi n m. Okay. So n represent the degree of the curve, degree of the curve. So we are defining this method particularly for general term. General term is having degree n. Any curve which have degree n. So first we find out phi n m. First we find out phi n m means take the nth degree terms. Take the nth degree terms. So find out phi n m by putting x is equal to 1, y is equal to m in the highest degree term. In the highest degree term. Highest degree term is nth degree term. You remember highest degree only we put x equal to 1, y equal to m in the highest degree term. So those terms which have degree n, just we put x equal to 1 into y equal to m in that terms. Now, second thing we do, so we put phi n m is equal to 0. So phi n m equal to 0 to find the value of m. So by putting phi n m equal to 0, we find out the value of m. Now, second step after finding the value of m, find phi n minus 1 into m by putting x is equal to 1 and y is equal to m in the next highest, means in second highest degree term. Second highest degree term. Second highest degree क्या होगा? That is n minus 1. Second highest degree term, that is n minus 1. So here we also write n minus 1, phi n minus 1. So remember this thing. Now we differentiate phi n m with respect to m. We get phi dash nm. We get phi dash nm. So just we will do these things now to obtain C. We use the formula. We use the formula C is equal to phi n minus 1 m upon phi dash nm. Phi n minus 1 upon phi dash nm. Or you can write down this as phi C into phi dash nm minus phi n minus 1 into m is equal to 0. So this is the formula for obtaining the value of C. Where we apply this formula? We apply this formula when we have a different value of m. So to find the value of C, by using above formula when m has distinct values. M has distinct values. Now we talk about the repeated values. The distinct value, you understand? So for distinct value means m having value uh, m1, m2, m3. Okay, so the values are distinct, they are not common. So we can use this above formula for obtaining the value of c. Now we move to the second case. Second case for finding the value of c. So when m, we discuss the case related to m. So when m has repeated values, so m has two repeated values. M has two repeated values means equal roots. So to find c by using the formula, so this equal to c square upon factorial 2 phi double dash nm plus c into phi dash n minus 1 m plus phi n minus 2 into m is equal to 0. So we need to obtain the n minus 2 means next highest term. Okay, so you remember. So here we are using phi n minus 2 means we require next highest term coefficients also by putting x equal to 1, y equal to m. So we write down, we need to obtain phi n minus 2. So phi n minus 2 by putting x is equal to 1 and y equal to m in n minus 2th degree terms. N minus 2th degree term. Now we talk about the value of m again. So if or when m has three equal values, m has three equal values. So when m has three equal values, so how to calculate c? So we calculate c by using formula. We take a cq upon factorial 3 phi triple dash nm plus c square upon factorial 2 phi double dash n minus 1 m plus c phi dash n minus 2 m plus phi n minus 3 m is equal to 0. N minus 3 equal to 0. So you remember these formula. So that means for two roots are equal, we start with c square. Okay, when no roots are repeated, so we start with c. You can write down c upon factorial 1, and the second we start with c square for two roots are repeated because we calculate the two value of c. When three values of m are equal, so we need three values of c, so we start with cq, phi 3, phi 2, phi, and simple phi. Phi, the third derivative, second derivative, first derivative, then function phi. Okay, so we need to remember these formulas. So for this is another method to solve the oblique asymptotes. So we take one problem related to these. So we start one question related to these methods. So we have one question. So find the asymptotes of x cube plus 3xy plus 2y square plus 3x minus 2y plus 1 is equal to 0. So this is x square. This is x square. So okay, so we start with basic problem. So we see that the given curve of degree 2. So highest degree of the given curve is 2. So the given curve of degree 2, so it means that there are two asymptotes. So there are two asymptotes of the curve. So this curve has two asymptotes. This curve has two asymptotes. So how to calculate the asymptote of the curve? So first we write down the given equation. So we write down the equation as x square plus 3xy plus 2y square plus 3x minus 2y plus 1 is equal to 0. So this is our equation number 1. So now we start with phi 2m. So highest degree is 2. So we put x is equal to 1 and y is equal to m in second degree term. In second degree means highest degree. Second degree means highest degree. So we write down as phi 2m. Phi 2m. So we see that. So when we put x equal to 1, 1 square is 1. 1 plus 3m plus 2m square. Okay. So this is our first equation. That means second degree terms. So we have three second degree terms. 1, 2 and 3. So in second degree terms, we put x equal to 1 and y equal to m. So we get this phi 2m. Now we move to the second lowest. Second lowest means first degree term. So means phi 1m. We obtain phi 1m. One first degree terms are, so there are two first degree terms. So two first degree terms that are 3x and 2y. So we put x equal to 1 and y equal to m. So when we put x equal to 1, y equal to m, so this gives us 3 minus 2m. So here we write down as by putting x is equal to 1, y equal to m in first degree term. Okay, so this is our equation number 2. This is our equation number 3. Now, first we obtain the value of m. So putting phi 2m equal to 0. So means highest degree we put equal to 0. So we obtain the value of m. So this can be written as 1 plus 3m plus 2m square is equal to 0. So this is a quadratic equation. So we have two roots. So how to obtain the roots of this equation? So we can write on 2 1s are 2. So simply first we write on 2m square plus 3m plus 1 is equal to 0. So we write down the factors as 2m square plus 2m plus m plus 1 is equal to 0. So here we take 2m as common. From these two terms we get m plus 1. From these two terms we take 1 as common. So we get m plus 1 equal to 0. So now the factors are m plus 1 into 2m plus 1 is equal to 0. So m gives us minus 1 or minus 1 by 2. So we have two different. So we see that the roots are the real and distinct. The roots are real and distinct. So for obtaining the value of c, we use the first formula. For obtaining the value of c, we use this formula. So c equal to, so for obtaining, so we write down for obtaining c, we use the formula c is equal to minus phi n minus 1 m upon phi dash nm. What is n here? So n is 2 because we have highest degree is 2. So we write a minus 2 minus 1 means phi 1. So phi 1 m upon phi dash nm. Sorry, this can be written phi dash nm. So phi dash 2m. So now this is our formula. So we need to obtain the phi dash 2m. So phi 2m is this. So we differentiate equation 2. So differentiate equation 2 with respect to m. So we get phi 2 dash m is equal to phi 2 dash m is equal to 3 plus 4m. 3 plus 4m. Now we put the value of this. So what is phi 1m? So the value of phi 1m is 3 minus 2m. So 3 minus 2m. 3 minus 2m. Phi 1m or 3 plus 4m. Phi 2m. Phi 2 dash m. Now put the first value of m. So put m is equal to minus 1. So we have first value of m is minus 1. So we get the first value of c. What is the value of c? So 3 minus minus plus is 2 upon 3 minus 4. So this gives us minus 5 upon minus 1. So means plus 5. Minus 1. So plus 5. So c equal to 5. So when m equal to minus 1, c equal to 5. Put the second value of m. So m is equal to minus 1 by 2. So we get c is equal to minus 3 minus plus, so 2 upon 2 upon 3 minus 4 upon 2. So this gives us minus the 2 to 1. So this gives us 4. Numerator is 4. 3 plus 1 4. Or this 3 minus 2 is 1. So this gives us minus 4. So this gives us minus 4. So we have two values of m. So we can obtain the two value of c. So then the asymptotes. Then the asymptotes are, so we write down the asymptotes in the form of y equal to mx plus c. So first asymptotes will be when we put m equal to minus 1, so minus x and c equal to 5. So minus x plus 5. So this is our first asymptote. You can write down this equation as x plus y is equal to 5. So this is our first asymptote. And for finding second asymptote, we have y is equal to m. So what is the m? Minus 1 by 2 into x, or c is minus 4. So you can write down this equation as x plus 2y. X plus 2y is equal to minus 8. So x plus 2y equal to minus 8. So this is our second equation. So this is our second equation. So we have a second degree curve. So we have two asymptotes. Both are real values of m. So we obtain the real asymptotes. Okay. So you can solve other problems related to asymptotes. So we obtain the oblique asymptote. Now here we discuss the parallel asymptotes. So we discuss about the parallel asymptotes. So how to obtain the parallel asymptotes? So for obtaining the parallel asymptotes. So when we obtain the parallel asymptotes, so we obtain parallel asymptotes along axis. So parallel asymptotes obtained along the axis. Now to obtain parallel asymptote, along x-axis. So put the highest degree coefficient of x equal to 0. If the highest degree coefficient of x is constant, so then there is no parallel asymptote along x-axis. Similarly, we obtain parallel asymptote along y-axis. So put the highest degree coefficient of y equal to 0. If the highest degree coefficient of y is constant, so then there is no parallel asymptote along y-axis. Okay, so you remember this thing. So when we are going to obtain the parallel asymptote along axis, so we take one example to understand the concept of this. So find the parallel asymptotes to x-axis of the curve x square y minus 3x square minus 5xy plus 6y plus 2 is equal to 0. So we write down given. The equation is x square y minus 3x square minus 5xy plus 6y plus 2 is equal to 0. So here we are obtaining the parallel asymptote along x-axis. So for obtaining parallel asymptote along x-axis, we put the highest degree coefficient of x equal to 0. So what is the highest degree of x here? The highest degree of x is 2. So this is the highest degree of x is 2. So that means we take the coefficient so of x square, highest degree coefficient y minus 3 minus 5xy plus 6y plus 2 is equal to 0. So the coefficient of highest degree term x square is y minus 3. So we put this term equal to 0. So we get the parallel asymptote along x-axis. So put y minus 3 is equal to 0. So gives us y equal to 3. So this is the parallel asymptote. Y equal to 3 is the parallel asymptote along x-axis. Okay. So some problems we have in this way, when we are obtaining the parallel asymptotes. So sometimes we cannot get the parallel asymptote of the particular curve, so we can get the oblique asymptote of the same. So we have some questions related to that. You can try. Okay. So one question we can take for find asymptote parallel to y-axis. Parallel to y-axis of the curve. So we have x square plus y square minus x square y minus xy square minus xy square plus x plus y plus 1 is equal to 0. So we do the solution of this. So given x square y square minus x square y minus xy square plus x plus y plus 1 equal to 0. So when we are going to obtain the parallel asymptote along y-axis, so we see the highest degree term of y. So here is y square and y square. So take the coefficient of highest degree term of y. So we write down as y square. Y square means coefficient of this is x square minus x minus remaining terms plus x plus y plus 1 is equal to 0. So highest degree equating to 0, the highest degree term. Highest degree term of y. So means x square minus x is equal to 0. X square minus x equal to 0. So this gives us x minus 1 is equal to 0. So we obtained as x is equal to 0 and x is equal to 1. So these are the required parallel asymptotes. So these are the parallel asymptotes along y-axis. Okay, hope you understand.